How to create a user-defined function for Maclaurin series using do, loop, until, or while condition structures in Excel VBA. This one is for sine series, sine x, for sine series. Now for this sine series, the sine series is equal to x minus x raised to power 3 divided by 3 factorial plus x raised to power 5 divided by 5 factorial minus x raised to power 7 divided by 7 factorial. Now, studying this series properly, you will come to realize that the sine of x, which the Maclaurin series will give you x minus x cubed all over 3 factorial plus x all over 5 divided by 5 factorial minus x raised to power 7 all over 7 factorial. Now when you look at it properly, this is the first term, this is the first term, this is the second term, this is the third term, this is the fourth term. Now you have the first term t subscript 1 equal to x, the second term t subscript 3, t subscript 2 equal to minus x raised to power 3 all over 3 factorial. And then the third term, which is x raised to power 5 all over 5 factorial. Now, having gotten this, if you look at it critically, let's look at the power of the x. Here now you have 1. Now for the first term, the power of x, the first term is 1, the second term is 3, the fifth term is 5. Now using when you look at the way the thing is progressing, you know it's an arithmetic progression. Now using arithmetic progression formula, where you have t subscript n equal to a plus bracket open n minus 1 times the difference. Now when you look at it, what is the difference between the second term and the first term is 2. Between the third term and the second term is also 2. So the common difference is 2. Now the first term is 1 plus bracket open n minus 1 times 2. Now you will have, if you open up the bracket, if I expand the bracket, you have 1 plus 2n minus 2. So that means you have 2n minus 1. So meaning that the powers of x is raised to power 2n minus 1. Now let's look at the factorial, the factorial down there. Now let's express all the terms in terms of factorial. Now you have the t subscript 1 to be x raised to power 1 all over 1 factorial. Then you have the second term to be minus x raised to power 3 all over 3 factorial. And you have the third term to be x raised to power 5 all over 5 factorial. Now if you look at if you study the terms critically, let's look at the first from the beginning. The first term has a positive sign, the second term has a negative sign, the third term has a positive sign, the fourth term has a negative sign. Now it shows that the even numbers as in terms of terms, the terms of the first, the second is negative, while the odd numbers is positive. So that means we have now gotten another expression showing that you multiply the terms with -1. So it will be -1 raised to power n minus 1. So that the even term will be negative and the odd term will be positive. So that the odd term will be positive. So now when I look at the factorials, now you have the first term, you have 1, the second term you have 3, the third term you have 5th factorial, and the fourth term you have 7th factorial. So let's look at this again. You have 1. Let's look at the series again for the factorials. Let me just say the factorials. You have 1, 3, 5, and 7. If we look at it critically again, you also noticed it's just the same thing with the powers. So this now implies that t subscript n will now be -1 raised to power n minus 1 times x raised to power 2n minus 1 all over 2n minus 1 factorial. So this is the nth term. So now let's say the k term, that is t subscript k, is bracket open -1 raised to power k minus 1 times x raised to power 2k minus 1 all over 2k minus 1 factorial. Now for t subscript k plus 1, now that meaning that anywhere you see k, you substitute with k plus 1. Now you have -1 raised to power k plus 1 minus 1 times x raised to power 2 into k plus 1 minus 1 divided by 2 into k plus 1 minus 1 factorial. Now if you look at it now, you have k plus 1 minus 1, so this will be k. So you have -1 raised to power k times you have x raised to power. If you expand this expression, this power, you now have 2k plus 2 minus 1 all over 2k plus 2 minus 1 factorial. Now if you simplify this further, you have -1 raised to power k times x raised to power 2k plus 1 all over 2k plus 1 factorial. Now let's look at the ratio of k subscript 1. So this case, t subscript k plus 1 divided by t subscript k. This will give us -1 or raised to power k minus 1 times x raised to power 2k minus 1 all over 2k minus 1 factorial times, okay, divide by minus 1 raised to power k times x raised to power 2k plus 1 divide by 2k plus 1 2k plus 1 factorial. So this is something as saying minus 1 raised to power k minus 1 times x raised to power 2k minus 1 all over 2k minus 1 factorial times. So if you put the times here, you reverse this term. Now we now have 2k plus 1 factorial divided by minus 1 raised to power k times x raised to power 2k plus 1. Now if you now bring together the like terms, you have minus 1 raised to power k minus 1, so you have it here. So using the law of indexes, it will have a minus to be k minus 1 divided by minus 1. Okay, no. This is supposed to be here, so here is supposed to be plus, here is supposed to be plus, this is minus 1, this is minus 1. Now here is plus, this is minus 1, this is minus, so you now have here to be here now is x minus 1 raised to power k. Now bringing these are like terms, bringing it together using the law of indexes, this should be minus into k minus 1 times, now the like terms will also have x here, say x raised to power 2k plus 1. So since it's dividing, this one is dividing this, so this will minus into 2k minus 1, or divide by 1 times 2k minus 1 factorial divided by 2k plus 1 factorial. Now if you open up this expression, that is this power, you have minus 1 raised to power k minus k plus 1 times x raised to power 2k plus 1 minus 2k plus 1 divided by 1 times, this is 2k minus 1 factorial divided by 2k plus 1 factorial. Now k minus, so k minus k plus 1, so you have minus 1 raised to power 1, which is something as minus 1 times. You now have 2k minus 2k will give you 0. So you have 1 plus 1 is 2. So x raised to power 2 divided by 1 times. Now you have 2k minus 1 factorial. So expressing the one at the denominator, this factorial at the denominator, in terms of 2k minus 1, you have 2k plus 1 times 2k times 2k minus 1 factorial. So this 2k minus 1 factorial will cancel out this 2k minus 1 factorial. You are now left with minus 1 times x raised to power 2 all over 2k times 2k plus 1 factorial. So that means you have 10k plus 1 equal to 10k times minus 1 times x squared divided by 2k times 2k plus 1. So this is the general formula that we are going to use to code the series for sine of x, the Maclaurin series. So this will derive the general formula we're going to be using. Now, so we'll now apply this formula. So now we're going to go into the Visual Basic environment. So how to go into the Visual Basic environment? You go to the Developer tab. From the Developer tab, you click the Visual Basic button. Now, if you don't have the Developer tab, what you do, you right click at the ribbon, click the Customize ribbon. You check this Developer tab, click OK, or you click the file, go to Option, go to Customize ribbon, check the developer here, click OK. That's all. Then when you click this Visual Basic in the Visual Basic environment, in this environment, that is where you will now write the code for that user-defined function. So let's now write the function, the user-defined function using that term. Now we'll now write function, we call it mark sine bracket open x bracket close enter. We'll now say dim, we'll define the variables we are going to be using, dim 10 and k, enter. We're going to say term is equal to x. So the first term, when you look at the series, the first term is x. So the first term in our program will now be, the first term will now be equal to x. So now we will now say the mark sine function, the first initial value will be 0. Now our k, the k should be 0. Now we're going to use the other do while loop structure, where you start with do, you enter. Now I will indent in. You say you mark, the mark sign is equal to mark sign plus 10. Now we'll now say k. Now I need to add an incremental value of k, so I say k is equal to k plus 1 and 2. Then the next one I'll just say term is equal to 10 times brackets open minus 1 times. So what I'm using is this formula we derived here. So this is minus 1. So it's a minus 1, the term times minus 1 times x squared all over 2k plus 1. So that's what we're going to use here. So you see this, the minus 1 times x raised to power 2 divide by bracket open 2 times k times bracket open close, say 2k 2 times k plus 1. Now you have 2k times 2 plus 2k plus 1. So this is the term. So now I'm going to say press shift tab. I will now say loop while our k, so while our k is less than, while our k is less than or equal to, let's say 100. Now if you look at the first one, the Maclaurin series for e raised to power x, we use do while k is less than or equal to 100. Then before the statement, then you loop. But for this one, you have the do, you have the statement, you now say loop while k is less than or equal to 100. So now let's test run this user-defined function inside Excel. Let's see whether it will give us. Now we're going to compare the result it's going to generate with that of the inbuilt function in Excel. So let's go there. So let's assume the value of x is 2. The inbuilt function is a sign, brackets open, okay, sign, press the tab key. You see, you now select the cell E9, bracket close, enter. So we have 0.9099. So now let's look at the Maclaurin series for sign E9, bracket close, enter. So when you look at what is the difference now, this value minus this value. So what is the difference? The difference is 0. let me go to home tab, format paint, select this. So there is no difference, it's just the same thing. So we are done with this user defined function we created just now. Thank you for watching. Have a nice day. You can subscribe to my channel, hit the notification bell, and also if you like this video you can also share it. Thank you. And again,